Hey there, Science 20. Okay, let's finish up our calculation lessons here. We're going to talk about molar concentration. Now, molar concentration deals with how many moles of a substance are found in a volume of solution. Now, just as a reminder from last year, mole is a specific amount of a substance. It's calculated to be 6.022 times 10 to the 23 particles. Because in chemistry, the atoms and molecules that we're talking about are so really, really small, we have huge amounts of them if we were to break them down to each individual atom or compound or molecular structure. So we've come up with this idea of the mole to help kind of put numbers into something that's a little bit more easy for us to understand and work with. So this is just going to give us a good measurement as to how much of a substance we have. And you may come across the word molarity in your readings, and that just is another way of saying molar concentration. Now, as I said, molar concentration is found by taking the number of moles, which the unit is in moles, divided by the volume, which is in liters, and we get our concentration, which is in moles per liter. And yes, your volume needs to be in liters. If it's in milliliters, we got to convert that into liters. All right. Now, as a quick little sample problem, we have a sample of water, take it from a lake. We have 100 milliliters of this sample. We've tested it and found that there are 0.0035 moles in that solution. So what's the concentration of salt in the lake? Well, again, we're going to set up our variables. So the number of moles is 0.0035 moles. Now you might be saying, can I convert that into 3.5 times 10 to the minus 3 moles? Yes. Not necessary, but you can do that. Here we have 100 milliliters. We know that we need to convert our volume into liters. So we take that 1 liter divided by 1,000 milliliters, multiplied by our 100 milliliters to get 0.100 liters. You see how the milliliters here are canceling each other out. So you can do that in this part of the formula where you're just basically putting your unit conversions here and then your final value we would leave here. And we're looking for the concentration. So now we put in our formula. We select the one that we want to use. Once we've made that decision, we plug in the numbers where they need to be. And then we come up with our final answer. And in this case, our final answer is 0.035 moles per liter. Now, if you leave it like that, I'm going to be fine. But you may also want to put it into scientific notation. That's fine too. By the way, not too much of an issue. I always want you to put your units in moles per liter, but sometimes you may see a measurement, 0.035 moles per liter. Sometimes they will abbreviate the units of moles per liter with a capital M. Okay, so this capital M is the same thing as moles per liter. Okay, you can use those two interchangeably with each other. Okay, now sometimes to find out the molar concentration, sometimes to find the number of moles, we actually need to find the molar mass. So in this case, this is something you were taught last year, or should have been taught last year. So the number of moles, MOL, equals the mass in grams divided by the molar mass in grams per mole. Now for elements, it's really easy. You just look at the periodic table and you find the molar mass and boom, there you go. But if you have a compound, so for example, let's find the molar mass of water. Not that we'll ever have to calculate it, but there's 2 moles of, or there's 2 hydrogen atoms in a water molecule, and each one has a molar mass of 1.01 grams per mole. And we're going to add to that the molar mass of oxygen. There's just one. Sorry, I keep putting those decimals in all willy-nilly. And yes, keep all of your digits for molar masses, keep it to 2 decimal places. So that's going to give us a total of 18.02 grams per mole. Okay, so that's how you find the molar mass of something. And from that, you can find the number of moles. Okay, so I've got a few different practice problems for you to work on with this. In this first case, we're looking for dissolving 30 grams of sodium sulfate into 300 milliliters of water. By the way, I like underlining the values, the variable values in the question itself to help me as I set up my first step here. So we need to find the number of moles of sodium sulfate. So we take 2 times 22.99. That's the how we figure out how much of the molar mass is coming from sodium. Each sulfur is 32.07, and each oxygen is 16.00. When we do all of this together, we have 142.05 grams per mole. This is then what we'll plug in here. And so the mass is 30.0 grams, the molar mass 142.05, and we get 0.21119 moles. We're going to round that to 3 sig digs, 0.211 moles. Okay, now to find the molar concentration, we're going to come down here. So we're going to take this number and we're going to plug it in right here. Now we're given the milliliters of water. But again, we got to convert that into liters. And so just really quick and easy, divide by 1,000. And you've got your volume in from milliliters into liters. Concentration is number of moles divided by volume. Now here, you can write down the 0.211 moles, but this is the value, the 0.21119, however it goes. That's what we want to be using to determine our molar concentration. Most of the time, it's not going to make a big difference. However, it might, and we want to be as precise as possible. So even though you can write the 3 sig dig value here in your calculator, please include as many of the decimal places as you can. Okay, we're going to divide that by 0.3, and we get 0.703977473. Round that for 3 sig digs, 0.704 moles per liter. Now, if we were to take the rounded number, the 0.211 moles, and divide that by 0.3, you're actually going to get 0.703. That would be an incorrect answer. I would dock you some part marks for it. Okay, so if you didn't use the unrounded value, if you use the rounded value instead, you would get 0.703 moles per liter, and that would be wrong. So we don't want to do that. Okay, so that's it for our calculations. So in our next lesson video, we'll kind of start applying what we've learned with these calculations to our everyday chemistry. So I look forward to seeing you in that.